All right, good morning, everyone. So today is Friday the 7th. If you guys could quickly, I'm just going to run through the agenda. I would like for you guys to do your homework check first. Go ahead and ask each other questions if you have questions from homework. And then if not, I'm going to ask that you guys get started with the warm-up, which is on page 7 in your notes packet. Ms. Stedman, once we're done the warm-up, we'll rewind back and answer any homework questions. I think I'll probably need about 20 minutes for notes, so just make sure that that time is left over in the end if you're going over homework questions. So go ahead and press pause for now, and then you can press play when we want to go over the warm-up. All right, so here's your warm-up. The acceleration of a body moving in a straight line is given in terms. So here's my acceleration. I believe the velocity is given at time 1. And then they're asking you this weird question. S sub 4 minus S sub 2. So let's just start off by writing out what we do know. This question should look familiar. It was given to you at one point. I pretty much told you guys. You didn't have to do the problem. Then the velocity at time equal to 1 is 25. So based on the lesson that we did on Tuesday, you should realize that just off of these two, I could find the velocity function. Okay? All right. So the question that it's going to ask me, though, is S sub 4 minus S sub 2. I'm hoping you can make this leap. If I was to find the integral from 2 to 4 of v of t, what would be the steps? First step you would have to find its antiderivative. Antiderivative would be the position function. Then f of b minus f of a. I was about to write a, which would be 2, which is actually the question. So pretty much this is all I need to find. So now it makes sense why they gave you this initial value, velocity of 1 equals 25. So I'm going to start off here with dA over dt is equal to, actually, I'm not going to even bother with notation for this because it's not in x's and y's and it may confuse you guys. So let's just start off with velocity is equal to 8t minus 3t squared plus c. The velocity at 1 is 25, so 25 is equal to 8 minus 3 plus c. So 20 is equal to c. So now that I know my c value, then I know my velocity function is 8t minus 3t squared plus 20. And if I wanted to find the answer to my question, S sub 4 minus S sub 2, that is equal to the integral from 2 to 4 of the velocity function, which is 8t minus 3t squared plus 20 dt. All right, so I am going to take up this space right here. And I'm going to go up this way. So my antiderivative would have been 4t squared minus t cubed plus 20t. F of 4 would be 64 minus 64 plus 80. Hopefully I just did that right. And then f of 2 is equal to 416 minus 8 plus 40. So that would be 48. Again, Ms. Stedman, if I make a mistake, please correct it. Therefore, S sub 4 minus S sub 2 would be the integral that's stated here. So my answer would be 80 minus 48, which is 32, letter D. So I was trying to give you kind of a trickier question than what you did on Tuesday, which probably was homework last night, using integration to find your C value, but I wanted to give you a question that may look a little different. It also reminds you that FTC2 can be written many different ways, and you do have to be aware of that. All right, so Ms. Stedman, if they have any questions from homework right now, you can take a minute or two to answer any dire, just they really couldn't get it questions. Otherwise, you can go ahead and get started. So, if you guys could open to 6 point, I think it's 4, day 1, I believe we're doing today. The chapter 6 is really out of order just because I found that I like this way better. So I'm actually going to not read this to you, but go ahead and just take a look. A separable differentiable function. So first of all, we're just going to start off with the fact that it is a differential. So that guy. It's a differential equation, that's why there's an equal. And then what you need to know is that we can separate a function as long as the function itself is multiply or divided. And the functions you're going to notice are a mix of x and y's. So taking a look, looking here, the reason why this one would be separable, so what we do is we physically separate the variables. So what do I mean by that? I'm actually going to multiply this side by dx, and I'm going to divide both sides by y. So what do you end up with? dy over y is equal to x times dx. So your y's are on the left side of the equation, and your x's are on the right side of the equation. This guy down here, I would multiply the left side by y squared, or both sides I should say, and then I would multiply the right side by dx. Okay, and my x's and y's are separated. And then the last one here, I would divide by this term to move that to the left side of the equation, and then I would multiply both sides by dx to get my x's to the right. So these are all considered separable, differentiable functions because we can physically separate them. Now, separation happens by multiplying and dividing. So the reason why these don't work, it looks so inviting to take this and subtract by y. So what you'll be left with is this. And once you're left with this and I want to multiply by dx, you get stuck because you're going to have to multiply everything by dx. So you get dy minus y dx is equal to x dx. And then again, you're stuck because of that. So you want to really notice that separable means that the x function and the y function, so this is the function in terms of x, this is the function in terms of y, that they are either multiplied or divided, and that's actually what makes the problems work out. Alright, so taking a look, what we're going to do is look at a harder one. Why is this one considered separable? So first of all, I'm going to rewrite it so that my y prime has a dy dx. And right now it definitely looks like it's not separated. So what I'm going to do, I'm going to try and move my dy dx to be on its own. So I'm going to move my x and y's to this side. So it really looks like it's not separated, but what I want you to notice is both of those terms have an x in common, which means I can factor an x out. And now that I did that, hopefully you noticed, now we can multiply both sides by dx. And then I can, oh sorry, that's supposed to be an x. I can divide by the 20 minus y. And we end up with 20 minus y is equal to x dx. Alright? We may actually come back to this question and complete the question depending on if I feel like we have time to do that. Alright, so separable differentiable functions. Now you're going to do a full problem. So you've pretty much learned how to separate. So I'm going to move this over. The y's to the left side, I do that by dividing both sides by y squared. I move my x's to the right side. And then the step that you now know from before was that we can integrate both sides of the equation. So these are a little bit harder than 6.1 because on the left side now you have a function multiplied by dy, not just dy. So I'm going to rewrite this one as y to the negative 2 power. And now we see that y to the negative 2 power, you're just going to treat it just like a normal function, like if it was x to the negative 2 power. So y to the negative 2 power, I'm going to add 1 to the power, negative 1, divide by it. So I actually end up with y to the negative 1 divided by negative 1 equals x squared, and then your plus c. So let's go back on the left side. Let's rewrite this so it looks a little nicer. Alright, and then one of the tricky things is that you are going to have to try and solve for y. So for this guy, if I wanted to solve for y, I would multiply both sides by y. And I get y times x squared plus c, and then I would divide both sides by the x squared plus c. Okay? I took some steps to show you how to solve for y in that case because I noticed a lot of people do some things incorrectly with reciprocals and not understanding how to use a reciprocal. So I did go through each step of solving there. That was very purposeful. So this guy, you're going to see this problem show up later. This k is a constant. It's a constant value. So I'm going to walk you through this one because it can be a little difficult. You're going to notice later on that it starts to look a little tricky. So let's start off with the fact that I'm going to separate. So here's what I'm going to do. I'm going to just divide both sides by the y, not the k times y. And then I'm going to multiply both sides by the dt. So this is what it looks like. The k stayed with the dt. That's just because it makes it much easier to have the k be a multiplied function on the right hand side. It just is. You can move it to the left if you really like to, but you'd end up with a k down here, and you'd probably take it out of the integration anyway. So integrate left, integrate right, and we end up with the ln of y is equal to, so a constant, the antiderivative would be times t, and then plus c. So here's a problem that you're not probably going to see this for homework, but I wanted you to get a heads up before we did this. I think we do this tomorrow or the next day. So if I want to get y by itself, I'd have to cancel my ln. I'm going to cancel my ln by using an e to all of that. So now, right now, can you please make sure that you wrote this whole thing as one nice power? That power is e to the kt plus c. Now I'm going to come over here real quick and say, what if I had x squared times x to the third? How would you simplify that? You would add the powers, right? And then that's how you get x to the fifth. Well, I want you to look at this going backwards because that's the rule I'm going to use. I'm going to take this guy and I'm going to write it as e to the k times t times e to the c power. So the k, let me actually give it a little bit more space so you really see it. I'm going to multiply by e to the c. And if you were simplifying it, you would add the powers because they had a common base, right? So the next piece, to eliminate an absolute value. We haven't done this much because we don't really like to mess around with absolute values. They are way trickier than you would believe. To eliminate this absolute value, you're going to need a plus or minus. So I'm going to do a plus or minus, and I'm just going to rearrange the order of these. I'm just going to swap the order. E to the c is going to come first times e to the kt. And then you're just going to have to take a leap of faith with me. You're just going to jump with me. This whole thing is a constant, meaning once I solve for c, there's no variable in that term. The t is over here. That being a constant means I can just rename the constant. So I can physically rename that whole, even the plus or minus, to a new constant. We're going to call that new constant a. You're going to see this again. You probably won't have one like this for homework. Please don't use a's rampantly. You probably will not use an a tonight in homework at all, but I wanted you to see it at least once, okay? So, Ms. Stedman, if you want to kind of explain why this happens, if they're really curious, you can do so if we have enough time right now. But this is going to be needed for later, so I wanted to try one. All right, next one. Separate the variables. So, separating, my y would come here, divide both sides, and my dx would go to the right side. This is actually a pretty difficult question. I've seen it on the AP, and I've pretty much seen a lot of people get it wrong. It's a substitution problem on both sides, meaning This left side right here, that is a substitution problem. How do I know that? Number one, it's not a rule. Number two, there is a chain rule hiding in there, or you can consider it a quotient. So this is definitely a quotient, or you can take this whole thing to the -1 power, and it's still a chain rule. There's no way to simplify it, and there's no way to graph it and try to find the area, so it has to be substitution. And hopefully you realize, well, the only thing I can really try and substitute is 1 minus y. So on the left side, let's do that problem first. I'm going to ask you guys to go straight through and do your substitution and come up with the left side's integral. So go ahead and do that. You can look up when you are done. Try not to just sit there and copy the board, please. All right, so let's just double check and make sure you're doing your steps correctly. Right here. So number one, I'm using a dy instead of a dx because there's no x's on this side. Secondly, I think some of you still need to see the step be done. I am going to replace the dy with a du divided by -1. And then I'm supposed to divide by 1 minus y again, and remember we don't do that, we multiply by its reciprocal instead. So that's where that extra -1 is coming from. So this becomes, remember we can pull that out front and you end up with the 1 minus y, we can replace that with the u, okay? So that's where I got my left side from. The right side, if you guys could do the same thing. So now because of the fact that we already used the u, I'm going to use a v. There is a product rule and a chain rule. Hopefully you notice that x squared is our v. How do I know that? Because the derivative of x squared is multiplied by dx. So dv dx is equal to 2x. How do I know that this is 100% going to work again? Right here, that derivative is multiplied by dx. All right, so dv divided by 2x is equal to dx. I'm going to show all my steps here so that you don't get lost. On the right side, I'm going to take the integral of 2x times e to the u, v, times dx, which is now going to be dv divided by 2x. What's nice is even the constant cancels. So I'm just left with the integral of e to the v dv, which is just e to the v, and then you're going to put your plus c back in there. All right, so we are only halfway done this question. We're going to have to take this negative ln of 1 minus y is equal to e to the v plus c, and we're going to have to solve for y. So maybe I was lying about that a thing. I'm pretty sure it's going to show up once again right here. So let's take this to the next page, and we'll try one more time here. So first thing I'm going to do, so I'm going to try to isolate this y. So you're going to go outside in. Outside in meaning, first I'm going to start off with getting rid of that negative out here. So I'm going to have ln of 1 minus y equals negative e to the v minus c. Okay? Next piece, I am going to use another e, I know it looks crazy, to eliminate my ln. We get 1 minus y, e to the negative v to the v minus c. And if you remember, this is where we can rewrite our e to the negative e to the v multiplied by e to the negative c power. The plus or minus is what's going to eliminate the absolute value. So I get 1 minus y is equal to plus or minus, and now I'm going to bring the constant piece in front, e to the negative c times e to the negative e to the v. I am going to make this a little easier on myself. first of all, I'm going to rename this whole thing as a, because that way it's a nice constant. And then I'm going to move y to the right and that whole term to the left. So I get 1 minus a e to the negative e to the v equals y. And in this case, just because it's a pretty complicated looking problem, we're going to leave it that way. I'm going to let you leave it with the negative exponent. Okay? Try another guy. So same thing here. I want you guys to start off by trying to separate on your own and get as far as you can. So same thing, Miss Demon, if you could let them work for a little bit. I will quietly start writing the answer up here, and then I'll go over the solution when you guys are done. Oh, Lord. I just realized. Sorry, guys. I'm going to pause you for a moment. I never substituted in my v back again. I was looking at that trying to figure out what looked funny. Miss Demon, if you caught that already, that's awesome. I'm going to fix it in my notes here. V was originally x squared, I believe. So I need my x's back. So there we go. I just noticed that while I was doing this guy. So e to the x squared plus, and this time I'll call c. Alright, so this one I just wanted to do because I wanted you to notice that not every problem is an ln problem. I start to notice that when I start showing that type of problem, then every single problem becomes an ln problem, and every single problem becomes a substitution problem, and so on. This one, the left side of the equation, we did not need substitution for. It was a simple polynomial. The right side was the substitution problem from before, so I just copied the answer. I am going to allow you to leave it this way because trying to solve for y in this would be a pain. You'd have to use quadratic formula to do so. So it's just to show you, notice we did not need ln, and that's because the 1 minus y was multiplied by dy. And then the fourth one here. So same thing, you guys should be working on your own, trying to separate your variables. The problem looks really similar to before, so go ahead and take a second and try to decide what you think you want to do. So real quickly, please, look on up here. I am curious how many of your groups at this point think that you're going to need substitution for the left side. Thumbs up for that. Thumbs up if you think you will need to just simplify. Thumbs up for that. Thumbs up if you think you can just graph it and find an area. And then last, thumbs up if you have no idea what you're doing and you have not figured out how to integrate it. Alright, so just to make sure we're on the right track, your u is equal to 1 minus y because it is a substitution problem. Why is it a substitution problem? Number one, we have a chain rule and we have a quotient. I could eliminate the quotient by rewriting it as the integral of 1 minus y to the negative 2 power times dy, but that's still going to be a chain rule. So I know 100% I'm going to need a substitution to eliminate the chain rule there. So du over dy is equal to negative 1. So du over negative 1 is equal to dy. I'm going to come down here. So the dy would be replaced by this. So I'm going to actually just pull my negative 1 in the front, factor it out, and then my du will replace the dy, and then divided by u squared. So we get negative integral of u to the negative 2 du, which then gives me add 1 to the power, divide by negative 1. That would just be the left side, and I end up with positive u to the negative 1 is just the left side. Therefore, I end up with 1 over the u, which was 1 minus y, is equal to the right side. If you remember, that was e to the x squared plus c. So here's one where I really want you to be careful on how you solve. I want you to go through the steps and not try something weird like just flipping fractions around. So let's go to the next page. Alright, so first thing I'm going to do, I'm going to multiply both sides by the 1 minus y. I'm going to divide by that 1, that e to the x squared plus c on this side. And then, oddly enough, because the y is negative, I'm actually going to add the y back to the left side, and then I'll subtract that term to the other side. So all I did was add y here, and then once I did that, I was able to subtract this whole other term to the other side. Okay? So that is actually the solution. Notice, number 1, there's no a here. I left that alone. It was not in the same form. Number 2, there was no ln in this problem. So what you should notice is I want you to know that dy or dx, whatever it is, over a y plus b. So that's really the form. This is an ln problem. Okay, that is how you can tell. If the denominator of your integral is a linear function of y, or dx over a linear function of x, that's how you know it's going to be an ln problem. This one wasn't linear. It actually had a squared, which eliminated it being an ln. The one before that, this one here, was multiplied, so that's why this one was not ln. And then the one before that was an ln problem for the exact reason I told you. The denominator was a linear function of y. Alright, so I think that should have been the last example. There you go. So homework tonight is number 2. And obviously the video will be up if you need to replay some of this. I know some of the stuff, because we're now combining substitution with a new topic, can be difficult, especially if you haven't mastered substitution.